Eccentricity is the idea of how round your ellipse is, and it's decided by how close your focus is to the center. The closer your focus is to the center, the skinnier it will be, and vice versa. Now, we're going to talk about the equation to find eccentricity in a second, but I want you to know that eccentricity ranges from 0 to 1. The closer your eccentricity is to 0, the rounder your ellipse will be. The closer your eccentricity is to 1, the skinnier your ellipse will be. Now let's talk about what eccentricity is. Eccentricity, your numerator is the distance from the center to the focus. The denominator is the distance from the center to the vertex. So let's use that in example 6. It says, find the equation of the ellipse whose vertices are here and whose eccentricity is this. So let's start by graphing what we know. I know my vertices are at plus or minus 5. Which does tell me a lot of information right here. So let's list our 6 things. So from just this information, I know where my center's at. Center's at the origin. That's always easy. I know that my major axis is right here because we called these points vertices, not co-vertices. So these vertices are 5, 0 and negative 5, 0, which gives me a major axis of 5 long at this line, which is y equals 0. Now, that's all I'm given except for the eccentricity. So let's talk about that eccentricity a little more. The eccentricity is the distance from the center to the focus divided by the distance from the center to the vertex. And in this case, we know our eccentricity is 1/4. Well, I know one of these distances. I know that the distance from the center to the vertex, that is this major axis. So the center to the vertex is my major axis length, which in this case is 5. And knowing that, I can solve for the distance from the center to the vertex. Times both sides by 5. And I get that the distance from the center to, not the vertex, the focus, is going to be 1/4 times 5, which is 5/4 or 1.25. Now notice, so my focus is 1.25 from the center. So we can graph that. 1.25 from the center, 1.25 from the center, and notice that that distance is our C. So we can say our foci C is 1.25, which gives us our foci at 1.25, 0 and negative 1.25, 0. So now I just need to find my minor axis and my co-vertices, which I can do using my C equation, just like I've done in the past problems. So I know that C is 1.25, and that equals the major axis, which I know is 5 squared, minus the minor axis, which I don't know, squared. And let's solve for this. So I get b is not a very pretty number. I'm going to make some room here. Give me just a minute. So in this case, I'm just going to write b as a decimal, 4.84. So my minor axis is 4.84. There we go. So now that I know my minor axis is 4.84 at, looks like that's x equals 0. And now I know my co-vertices, 0 and 0, negative 4.8. Now, keep in mind, I am not actually done yet because this is just graphing, but I was not asked to graph this problem. I was asked to come up with the equation. So now that I have all this information, now that I've graphed it, I know what this ellipse looks like. I used the eccentricity to come up with all the stuff I needed to know. Now my last step is to actually come up with my equation. So here's our equation. My center is at the origin. My side-to-side axis, that's the one that goes with x, was 5. And my up and down axis, that's the one that goes with y, was 4.84. So I get x squared over 25 plus y squared over 23.4375 equals 1. And there we go. That's the equation for this ellipse. We only have one problem left to do, which is a story problem with an ellipse, and then we'll be done.